Hi everyone, welcome to the Photobiology Unit's YouTube channel and welcome along to today's presentation, which is going to be on the direct to indirect ratio that's used during UV phototherapy. This comes as a direct request from one of our viewers. Before we get into it, please do check out our website, which is at photobiology.scot.nhs.uk, and also check out our other videos on this YouTube channel as well. If you've got any ideas for videos that you'd like us to do, or even if you'd like to do a video yourself, please do get in touch with us, and remember to like this video, give us a thumbs up and subscribe. So to calculate the direct to indirect ratio, we need two things. We need some direct measurement and we need some indirect measurement. Now the way you do these measurements is absolutely critical to the answer that you get out at the end. And now remember, the whole purpose of doing this dosimetry is so that we can try to recreate the irradiance, the power per unit area that's falling patient's skin. And that's where the direct measurement comes in. Now it's important at this point to say that the health and safety executive do not like members of staff going into phototherapy cabinets to take measurements. And the reason for that is that the staff member that's in there will only be protected by personal protective equipment. And in terms of the hierarchy of controls, personal protective equipment is at the very bottom of that hierarchy. And so there's a greater risk that if it fails, that the individual will then be harmed by that. What I would say though is that if using another technique to do the direct measurement, such as using a phantom, you have to be absolutely sure that the phantom is representative of a person and that your measurements are representative of the light that would be falling on an individual's skin, because that is ultimately the clinical purpose of doing these measurements. Determining the light that falls on a patient's skin is not an easy task. If you see this image here, which was originally from Brian Diffie and has been adapted and implemented into the British Association of Dermatologists and British Photodermatology Group guidelines on dosimetry, there's a link in the comments section below. You can see here that the distribution of the UV radiation around the body varies quite a bit. So how do you do your measurements to represent this? Well, in Dundee we use the Scottish UV dosimetry guidelines technique, so affectionately known as Scooby-Doo. And with this technique, a direct measurement requires 12 measurements in one direction, then a rotation and another 12 measurements, so 24 measurements all in total. The measurements are taken at chest, waist and knee height. They're started with the right shoulder, centre of the chest, left shoulder and then back. The same at waist height, right, centre, left and back, and the same down at the knees as well. So those 12 measurements are taken facing one side of the cabin, and then there's a 90-degree rotation and another 12 measurements are taken. Here's an example then of the calculations that are done in order to get the direct to indirect ratio. These are our direct measurements that I've just described, the technique that we used to get those. You can see made it chest, waist and knee height, left, front, right and back. So 24 measurements in total. An average of all these measurements is taken to get the direct measurement result, which in this circumstance is 5.32 milliwatts per centimetre squared. The indirect measurement then, well, indirect measurement techniques vary. The method that we use is we take a UV detector mounted onto a clamp stand, and that's placed inside the phototherapy cabinet. A repeatable distance, normally that's 30 centimetres, but in some of our cabinets that are a bit smaller, we use a shorter distance. That distance we try to use to represent the distance that the patient is from the side of the cabinet. But what's important is that the technique is repeatable. So the detector is placed 30 centimetres from the tubes inside the cabinet, and measurements are taken at left, middle and right of each of the sides inside the phototherapy cabinet. So left, middle and right, 90-degree rotation, left, middle and right, and so on. So we get a total of 12 measurements overall, and the average for these indirect measurements in this scenario is 6.832 milliwatts per centimetre squared. The direct to indirect ratio then is very simply the direct measurement divided by the indirect measurement, which gives us a result for this particular phototherapy cabin of 0.78. Now, if you look at the literature, there have been some direct-indirect ratios reported, and you'll find that 0.78 is in the same region as a lot of these ratios. If you decide just to use a ratio that comes from the literature, it's very important that you're following exactly, or as close as you possibly can, the measurement techniques that they have used in those publications. And that's because this direct to indirect ratio is very critically dependent upon your measurement technique. It's also dependent upon the phototherapy cabinet because of the geometry of the phototherapy cabinet, and theoretically it's also dependent upon the detector that you're using as well, primarily because of the angular response of the detector. So if you have two detectors, one with a poor angular response and one with a good angular response, you're going to have a different direct to indirect ratio. Why is the indirect measurement higher than the direct measurement? Well, that's because the direct measurement has an individual or a phantom inside the cabinet, and they're blocking some of the UV radiation from reaching the detector. Whereas in the indirect method, there's no physical body in the way, so ultraviolet radiation from the one side of the phototherapy cabinet can travel to the other side of the phototherapy cabinet, reflect off the reflectors, and then enter the detector. So you get an artificially high result compared to if there was somebody inside the phototherapy cabin. And that's the whole reason for doing the direct to indirect ratio. You'll find a good flowchart inside the Scottish UV Dosimetry guidelines that lays out how the measurement process should take place. What you're ultimately trying to do is determine the designated patient irradiance, the DPI. Now that I've shown an example of the calculation of the direct to indirect ratio, let me show you an example of how that's then applied to some indirect measurements in order to get this designated patient irradiance. This is the spreadsheet that we use to calculate our treatment times for different doses of radiation that we want to deliver. It's important you're confident in your spreadsheet because it will have a direct impact on patient treatment, and therefore any errors in this sheet could potentially cause some serious harm to the patient. Therefore, it's a good idea to develop these spreadsheets under a quality system. We use ISO 9001, and the way we verify our documentation is that we create a template which is then verified against manual calculation. Once it's been verified, the spreadsheet's shut down and is entered into our document control system so that the spreadsheet is completely protected and data can only be entered into certain cells. And in this instance, you can see here, these are the salmon coloured cells. So we have data on our UV meter, our detector, the filter that's used, and the diffuser as well. The spreadsheet's for indirect measurement, and I've already described the indirect technique that we use, the 12 measurements with the detector and the clamp stand. So that's these values you can see I've highlighted here, and the resulting mean. This particular detector requires us to apply a correction factor in order to get the true irradiance traceable back to national standards. That correction factor for this detector is 5.9, and we also then need to apply the direct to indirect ratio, which, as we saw from earlier in the video, was calculated at 0.78. So multiplying the detector reading by the correction factor and the direct to indirect ratio gives us a final designated patient irradiance of 4.98. That then informs the time of exposure to deliver the various doses. There's a couple of publications that I can highly recommend that you read through. One is the Scottish UV Dosimetry Guidelines, and the other is the Guidelines on the Measurement of Ultraviolet Radiation Levels in Ultraviolet Phototherapy, which comes from the BAD and the BPG and was published back in 2015. Another good location for information on UV phototherapy is the Photonet website. Photonet's the national managed clinical network for UV phototherapy in Scotland. They have a professionals area, which when you go into it, you'll see there's a standards and protocols section, and in there are the Photonet dosimetry protocols. It's an easy to read document that provides some useful information. So I hope you've enjoyed this video. If you have any ideas for future videos, please get in touch with us, or even if you'd like to do your own video, we can upload it onto our site. Take care and stay safe.